Right. So this is hands-on with Fedora Atomic. I kind of wish Ian was here because he is actually on the Atomic project and I'm not. So he's a little bit better of a person to answer some of the questions that are going to come up, but I will do my best. And I'm just going to jump right in, ask questions as we go along. Otherwise, there's a demo at the end, and I'll be happy to take questions after that. So I'm going to start at the top with what Fedora Atomic is. Fedora Atomic is a minimal OS. It's designed to run Docker containers, and we're going to talk about what Docker is and a bunch of other buzzwords, because Docker is a pretty hot buzzword. But we'll start with the stripped bare OS. The OS we're talking about is either Fedora or RHEL or CentOS, cut down to the absolute bare minimum. And then we pile on top Docker, Kubernetes, etcd, Flannel, and Cockpit. And I'm going to talk about each of those components as we get to them. I can't talk about Docker without putting in this awesome animated GIF of Dan Walsh saying Docker, Docker, Docker with his brilliant Northeastern U.S. accent. Docker, Docker, Docker.
Is that the SE Linux guy?
That is the SE Linux guy. So Docker, for the purposes of Atomic, we're talking about Docker as a format for applications packaged as Linux containers. Docker, the software company, produces lots of other software. None of that software is really relevant to Atomic. Kubernetes is container orchestration. This is a project that comes out of Google, but Red Hat is partnered with them in particular for OpenShift, but also to get Kubernetes packaged into Atomic. Even Google acknowledges that this is a stupid name for a project. It comes from the Greek word for a person steering a boat, so there's at least some sort of definition in there. We're not going to talk about it much in this presentation, mostly because I have not gotten my head around it. It's a fairly new addition to Fedora Atomic. But the rundown is an application managed by Kubernetes becomes composed of a group of single-purpose containers called a pod, and the Kubernetes pushes it into a cube, which schedules the containers and manages shared resources. Again, it's a big thing. etcd is a distributed key value store. It's a product of the CentOS group. It is used to distribute small bits of data. It's required by Kubernetes, and so we're not going to talk about it a whole ton here. But it's part of what Kubernetes uses to manage and figure out what's where. Flannel, another thing we're not going to talk a ton about. It's software-defined networking. This is a very, very new addition to Atomic. And Atomic, I'm going to apologize a little bit because Atomic is so new. It's changing a lot. So these three pieces were added fairly recently. It's a product of the Core OS group. It's a very new thing. It's used to emulate Google Compute Engine has a set of networking capabilities that are not available outside of Google Compute Engine, and so it's basically a way to get that outside of Google Compute Engine. One component we are going to talk about is Cockpit. This is a friendly web UI. It's a project of Red Hat and Fedora. I've heard it internally referred to as how I manage Linux hosts from my iPad. It's very pretty and very friendly and very useful, I hope. And we'll talk about that a little bit. Another component is RPM OS tree. This is Git management for your operating system binaries, or Git-like management for your operating system binaries. It comes out of the GNOME OS tree project. And I'm going to take this opportunity to request that you do not mess with the OS tree. But we'll get to that a little bit once we start the container up, or the Atomic system up. And you can roll your own OS tree as opposed to what you get from the Atomic distribution. But if it breaks, you get to keep all the pieces. Anything and everything else that you run on Atomic goes in a container. And I can't stress this enough. That makes sense for applications if you're familiar with Docker. If you're not familiar with Docker, we'll show you a little bit about that. But it also includes your management agents, so your Puppet agents, your Salt agents, monitoring agents like Zabbix, backup software, security scanning. All of that stuff needs to go in a container on your atomic host, which begs the question, how does your container, which is supposed to be in a jail, get to all the other containers and to the host itself? Which brings us to the topic of privileged containers. So privileged containers are a new feature of Docker. They get access to the host OS's process list, file system namespace, and pretty much anything else you want to give it. We are just now recently shipping a container called Rel Tools, which contains a bunch of stuff like Nmap or a bunch of expanded process tools and a ton of other stuff that you might need if you want to diagnose a problem with your host, and it runs in a container and can access the other containers. SE Linux. You are going to want SE Linux on any host that does Docker operations. Dan Walsh, who was the guy with the Docker, he likes to say over and over, containers do not contain. They're not a cheroot jail, really. Containers are a namespace, and not every part of the operating system runs in a namespace today. The parts that are not namespace can potentially slip out and allow people to attack allow containers to attack each other or the host, or leak information from one container to another that you don't want. SE Linux is your force to stop that. You can apply what are called Mcs Labels to make sure that they're attached to containers and make sure that containers can't talk to each other or stomp on each other. And C groups, another feature of Atomic, but this is actually also a feature of RHEL going back to 6 and Fedora going back to 15. These are fine-grained resource limits, things like CPU memory. You can give containers higher priority or just keep containers from hogging the system away from everyone else. And one of my last points here is storage. Storage gets weird really fast with Docker. Docker containers are meant to be immutable. The Atomic OS is meant to be immutable, which means they don't change. So when you need to make a change, you either change your Docker container or you tell your application to store the data somewhere else. Atomic itself uses LVM via device mapper to allocate data or storage for Docker containers, and Kubernetes has features for shared and distributed storage, but it doesn't manage storage itself. You can also use network storage, and yeah, it's a point of contention and a strong consideration when you're talking about containerized operating systems, and that's really best to answer or deal with in the QA section. Upstream for Atomic is different from RHEL. So in the Atomic space, they have proposed what they're calling the 246 model, where there's a new spin of Fedora every 2 weeks, or Fedora Atomic, a new spin of CentOS Atomic every 4 weeks, and a new spin of RHEL Atomic every 6 weeks. Again, contrasted to where the normal distro flow is Fedora into RHEL into CentOS. And with that, we're going to jump right into the demo, because that was a lot of stuff to throw at you, and I'm hoping it will make a little more sense once you see it. All right. Oh, that's an annoying prompt. And I can't see this from here. Yeah, all right. I'm going to kick this instance off with, boy, this is awkward, with Ansible. And I am not going to talk a lot about Ansible right now, but Ansible is awesome. And if you guys want a talk on it, I will be happy to do one. I'm sorry?
So do we have time?
To talk about Ansible? Not this go around. Wait a minute, what? Oh, okay. I forgot the very important step of loading my keys, which is right here in my notes. All right. Here we go. Little pro tip for anybody doing a demonstration on AWS: create a specific set of key and create a specific key for your presentation and then delete it afterwards, because you never know if you're going to accidentally dump it to your terminal and get it videotaped. All right, so this runs for just about a minute, and then I can go back to trying to type with my head. Yeah, this is going to be fun. All right, you know what? I'm just going to turn around. I'm sorry for the people behind me, but I cannot see a thing here. Am I in Tmux even? No. Life is hard.
So what is at least theoretically happening at this point?
We are launching, and I was going to point to my GitHub repo with this. We are launching Atomic on Amazon Web Services right now.
And I assume that they're not, how did you get the Amazon instance up there? Did you upload it yourself? Or?
No. So, okay, that's a great question, and I should show you that. Actually, you know what? No, I'm going to... Oh, you suck. You got tiny text here. All right, I'm just going to wait for this to finish. But what you're interested in here is this AMI. This AMI is published by the Fedora project, as in projectatomic.io. You can find it there. So this is the AMI that Fedora is publishing right. Actually, it might be a couple of revisions past. I did that on purpose because I wanted to be able to show you guys an OS update. But once this gives me my command line back, I'll just show you the playbook. The playbook is on my GitHub repository. It's github.com/stenwt in the MISC repo, and then Ansible playbooks. There's a playbook that you should be able to just throw into Ansible and launch this yourself if you set your AWS credentials properly.
What's an AMI?
Amazon Meta Image. You know what? I don't know what the M stands for. Machine image. There you go. Thank you. Yeah. So Amazon expects images that you launch to be packaged in their format. And yeah.
From what I understand, it's kind of like a live CD, right?
Right.
It boots up.
That's possible. I've never heard that.
Well, just as an analogy, you get this running instance, but there's no persistence. So once it goes away.
Yeah. That can be the case. So this is the playbook in question, and what it does is fairly simple. It creates a VPC, which is a virtual private cloud, which is a network within Amazon's space. And we do that because we're using hardware virtualization, HVM. That's the T2 Micro here. So this is one of their smallest machines. I've got the link here to where you can get the AMI number for the AWS image. We're launching it in US East 1C. You can change the environment name to anything you want. That's just the text. And blah, 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 blah. So we enable SSH. We enable HTTPS. We enable Cockpit. And I'm throwing my public key up onto AWS so I can SSH into it. Straightforward if you're familiar with Ansible. And if you're not, like I said, I'll be happy to talk about it. Yes, I really want to do that. All right, here we go. Release. All right, so here we are on a Fedora machine on Amazon's services. Oh, that's obnoxious. Why didn't I put that? I can only have one terminal up at a time because of reasons. Sorry, I have my notes in a terminal, and oh, you know what? I can just not have them in a terminal. How about this? I'm going to... Yay. Okay, now I can do everything at once. No. All right. Are you kidding me? Oh, I get what's going on here. Okay, I think that should stop the pain. Yes, all right. That was fun. Sorry. Okay, so now we're on our atomic host, and we're going to take a look at the process list just because this is supposed to be fairly minimal, right? And we got a bunch of kernel processes, and we got dbus, and we got systemd, and we have a Getty, and we have DH client, and that's it. SSHD is running. How about... We're using 778 megabytes, not the smallest distribution you've ever seen, but it's pretty small. La, la. 310 packages installed, not a ton again. And we're not listening on a ton of ports here either. You'll notice systemd here is listening on 9090. That's going to be coming into play later. We got our DH clients listening, we got SSHD listening, and that's it, isn't it? Yes, that's it. So this 9090 is our Cockpit instance, which I'm going to hop onto right now. Hey. That's awesome. Okay. Okay, I think I need to file a bug on GNOME. There we go. All right. So this is my host. And yes, I'm really going to accept the self-signed certificate. Oh, but we forgot a very important step. So Cockpit is a friendly web UI, like I mentioned, that lets you manage a Linux system. It uses the Seriously. It didn't do this last. Epiphany. All right, now we have our lovely, friendly web UI that lets us do all kinds of stuff with our host from the web. So this is our host. You got CPU, memory, disk I/O, network traffic graphs there, system information. You can. This is an IPA domain they're talking about that you, in case you want to join one. Where did my stuff go? Goodness. You can see networking information. You can manage bonds and VLANs from this interface. You can manage file systems and logical volumes from this interface. You can create RAID devices. All this stuff is talking to systemd and the various services that it talks to. So it's talking to the device mapper. It's talking to the network manager. And so this is one of the advantages of moving to systemd that we get from in RHEL and Fedora. So I'm not authorized to access from this account. And what this is telling me is that, so Cockpit uses the system authentication system. So if you're hooked into PAM, LDAP, if you're hooked into IPA, it's using your system credentials, the same credentials that you would use to log in to the machine and do stuff. It's doing stuff as you. So if I flip back to my terminal here, and I do, here, there's my Fedora user running the Cockpit agent and the web service, WebSocket. All this stuff comes up and goes away as people log into and out of Cockpit, which is why the only thing that you see when nobody's logged into Cockpit is systemd listening on the port. So in order to be able to have access to do this kind of stuff, I need to log in as root or an administrative user. All right, so now if we go back into I don't know if I pulled up the journal, but running as Fedora, the journal section was empty. And here you can see everything that journald sees, since we're logged in as root this time. And so what I'm going to go down here to do is fire up a couple of containers. You'll see the combined CPU and memory usage here of the running containers, which there aren't any just yet. So let's just grab a real easy one. Not, well. So you can see it's going to go off and pull the Docker image. And while that's downloading, we'll grab another one.
Where is it getting the Docker images from?
These are coming from the Docker registry. So if you go to docker.io, they have their own registry that contains all this stuff. And you'll probably hear a lot about this going forward because the upshot is that any idiot can upload something that calls itself Fedora Own Cloud. And if you're not careful about which image you pull, you could pull something that's potentially malicious. So now that we've got the BusyBox Docker instance up, I'm going to kick this off. And I'm going to put a memory limit on it. This is going through C groups, like I said before. And I'm going to drop the memory allocation way down because BusyBox doesn't need much. I'm going to run it with a terminal, and off it goes. You'll see my memory spike up to like 900 kilobytes used. Running, started. Yeah, it's using 0.9 megabytes of 41 allocated. Woohoo! And are we done pulling? No, we're still pulling over here. So Docker containers are made up of different layers that are, you know what, I'm not even going to go down that road because I'm going to paint myself into a corner where I don't know what I'm talking about. Sorry. Downloaded. There's probably some more layers to go.
Can you talk about how the sudo file looks in the atomic? So etc sudo, you look like you sudo password reset root.
Yeah. So sudoers is being populated in this case by Cloud Init, if you're familiar with that. When you launch an image on Amazon Web Services, there's a sort of a set of conventions called Cloud Init that allows them to populate things like sudoers with data that you have allowed. So when you launch this AMI in particular, Cloud Init says give the Fedora user access to run all commands as sudo without a password. They don't particularly want you.
And is Cloud Init an Amazon Web Service convention, or?
It's been adopted by just about everything. You can run it on OpenStack. You can run it on what's the other big one? Rackspace. Yeah, definitely worth looking into if you're launching stuff on third-party services. Still pulling layers. Actually, while that's going, I should hop over here and kick off something else that's going to have to spend some time downloading. So the RPM OS tree capability that I mentioned, that is how you update and maintain your system image. So if you try to add a package, sudo yum's not here. If you actually go out, if you get all head up and decide you're going to install the package anyway, you will find out fairly quickly that you can't even create a lock on the yum directory. The file system is mounted read-only. So if you want to add packages, you're basically going to be dropping them in opt and running them that way. And even that is not something I would recommend. So the way you're going to update your system is sudo. There's two ways to do this. Is it? Yes, it is. Okay. Atomic is a symlink to RPM OS tree. That's fairly new. I think it's a marketing thing. So the way has been OS tree upgrade. So I'm going to go grab the latest updates. And has my Docker image? Yes. All right. So OwnCloud is up. And I'm going to kick it off. And one of the things you can do with Docker is run a service on a port and tell it what port on the host to use. So I'm just going to bind it to the 443. Run it. What's going on here? Did I miss something? This doesn't. Oh, how did I get there? Okay. Yes, okay, OwnCloud is up and running, taking 37 megabytes of memory, spiked up the CPU a little bit. Let's go back to our browser. Oh, I'm in the browser. Where is my URL bar? Good grief. I can't see what I'm doing here, sorry. All right, so I'm going to lose my URL bar again. Self-signed certificate. You'll notice I'm getting prompted for this again because this is a different certificate for a different HTTPS server. And does this work? I can't see what I'm doing here. Yeah, I just missed. There we go. There's OwnCloud already up and running without us having to do anything.
I like how on the login page it tells you we have a very weak password.
Mm-hmm. Welcome to OwnCloud. Yay! And so I ended up playing oh, okay. Let's get back to our OS updates. So here you can see what just happened with OS tree. It updated a bunch of packages. It pulled in Flannel because Flannel's new. And I want you to do a reboot to reboot. Actually, before we do that, we're running kernel 3.17.4.301. We just picked up, is there a kernel update in here? Yes, 3.19. So we're going from 3.17 to 3.19.
What does Flannel do?
It's software-defined networking.
What sort of applications would you use that for?
Particularly, it's there for Kubernetes. So when Kubernetes wants to create a network space that's particular to an application that's composed of a group of containers, it would use Flannel to define networking in between those containers. Any other questions while we're waiting for the host to reboot? I have another reboot after this, so queue up your questions.
So, are you going to show off like how like reverting the OS?
Yes, that's my next reboot.
How would I make my own PMOS tree?
That is a great question that I don't know the answer to. I know it is possible, and you would probably want to start with the RPM OS tree documentation.
It only says to do.
Oh, really? That's unfortunate. I would file a bug on that.
So what have you done so far in case I haven't been able to follow along?
I have fired up Fedora Atomic. I logged into Cockpit and showed you that. I changed the I set the password on the Fedora user so that I could log in as Fedora. Logged in as the Fedora user. Showed you that the Fedora user can log in, see some of the system stuff, but not everything. Set the password for root. Showed you that root can see everything. Pointed out that the Cockpit system uses a systemd socket to hold the connection open, and then only fires up the Cockpit web service when it's actually needed and as the user that's logging in. So when you log in as root, you can do things as root. When you log in as yourself, you can do things as yourself. From there, I brought up a BusyBox Docker container and a OwnCloud Docker container. And then I just updated the operating system. So if I go uname-a, we're running kernel 3.19. And so what a lot of people are very interested in is being able to roll back OS updates. If you go RPM OS tree rollback, and is it going to ask me for, no, it's actually going to just go right to the most recent one. I'm just not even going to use the... So we just rolled back that entire update, which you can do in some cases with yum history on, for example, RHEL 6 or Fedora. Oh, when did they add that to Fedora? I have no idea. I think it was in 15 or 16. You can do yum rollbacks, but this is your entire operating system.
It's a rollback of the small OS component, but the Docker containers stay.
The Docker containers don't change.
And it rolls back the entire update, not just like,
Yep,
not just tmux.
absolutely. Yeah, I don't think there's any convention within Atomic. No, there is not a convention within Atomic to just update one component of the Atomic host.
I have a question. I'm a newbie when it comes to this Docker,
Mhm.
completely VM. And a little bit of perusing that I've done, they talk about Docker or Docket, whatever things called, versus Rocket. Is there a
Okay, so Docker is their own project, their own company. They're an open source product. There's some politics around who has been allowed to make changes to Docker. And so there's another project that's very similar to RHEL Atomic or Fedora Atomic called CoreOS. And CoreOS is, they have one product, and it's an operating system designed to run Docker containers. They have been submitting changes to Docker to do things like run Docker containers from systemd instead of what they have, which is the Docker daemon, because they don't like the Docker daemon. It doesn't work very well. And so Docker, because they want to protect what they see as a potential future business model, they just close the pull requests. They're not accepting certain types of changes that they see as not interesting to their business model. And so CoreOS is forking Docker and putting out a project called Rocket, which does almost exactly the same thing, but they have control of it. And so it's a competing but compatible and similar project.
so it's a competitor?
Yeah, it should be.
So they have like two people screaming at each other, mine's better, no, mine's better, no, mine's better. That kind of stuff.
Well, it's more like you didn't accept my changes, so I'm going to take my ball and go home. I'm going to do it myself. I'm going to build my own Docker with blackjack and hookers.
And by you giving this talk, you're on the side.
I am on neither side. Red Hat actually has its own sort of container format called systemd something. I don't know. It folds into systemd. And we don't push it because Docker has an enormous amount of traction and momentum. And I mean, we've had our pull requests into Docker closed exactly the same as CoreOS has. And we've had a lot of the same problems they've had. So from that perspective, Rocket is interesting. We're not going to stop working with Docker. We're not going to refuse to work with CoreOS. All right, so I rolled back. We're now back on kernel 3.17. I could roll forward. I could reboot. I can do this all day. But yeah, that's Atomic in a nutshell. That's all I've got as far as the demo goes. So if you want to go to questions, we can go to questions.
So can I run Fedora Atomic on, quote, real hardware instead of?
Absolutely. There are installer images up on projectatomic.io. There are for Fedora. I don't think there are for CentOS yet, and for RHEL, I don't think we're even there yet. The way we're distributing Atomic right now is there are QCOW images, which you can run on OpenStack or KVM or whatever virtualization engine you're interested in. If you want to run it right on Metal, then there is an installer for Fedora 21, maybe 22 Atomic. But not yet for CentOS or RHEL. My personal hobby is trying to get this to run on a Raspberry Pi 2, because I think that would be fun. Any other questions?
Just what is Origin? I see that on the
Okay, so part of the reason I'm interested in Atomic is because I work on OpenShift. OpenShift is Red Hat's platform as a service. The three forks of Origin or of OpenShift are Origin, Online, and Enterprise. So Origin is the open source upstream version of OpenShift. Online is what I deal with day to day. It's a fork. It's a couple weeks behind Origin, and then Enterprise is a fork behind that.
Are those all Red Hat?
Yes.
things?
Yeah. I mean, they're open source. Anybody can contribute. It's on GitHub. We have some pretty major contributors who run our stuff. But yeah, Red Hat is the major force behind OpenShift.
So what is like the long-term thing for Atomic? Is it going to like become kind of the de facto Fedora in like 5 releases or something like that?
I would be shocked if it was the de facto Fedora. Where I sort of envision or imagine Fedora Atomic as, think about what let's say the VMware or your KVM hypervisor. This is more what you would run in place of that. So if you want to run containers instead of virtual machines, which a lot of people are interested in because they're lighter, they're faster, they're better at certain things, that's, I think, where you're going to see a lot of it. My interest as somebody who works on OpenShift is we're looking heavily at OpenShift version 3 is going to run almost exclusively, well, no, it's going to be targeted at the Atomic distributions. So it's going to run on this stripped down tiny OS, and we're going to run customers' applications on top of it.
Any container high availability stuff on the horizon?
That comes out of Kubernetes, and I'm hoping I can have something reasonable to say about Kubernetes in the next couple of months, just in terms of my own edification and my own ability to talk about this stuff intelligently.
So would Project Atomic be a replacement for OpenStack Nova then? The compute layer of OpenStack?
No, no. Actually, one of the things I'm hearing about is running. Today we run OpenShift on top of OpenStack in our lab. One of the things we're talking about is running OpenStack on top of OpenShift. So what that would mean is your OpenStack cluster comes as an application definition that gets deployed into OpenShift in containers. And OpenShift manages the containers for you, and you run OpenStack that way. So no,
So you have VMs running containers running on Metal.
Yes. Yeah, potentially.
What's the benefit of doing it that way?
So containers run closer to bare metal performance. They start up much more quickly because they're just a process. You don't have to like go through BIOS and all the stuff that you normally do on a VM. Containers are lighter. They're easier to transport than VMs. And I don't know. I'm probably going to have to come back and do a Docker presentation for you guys at some point because there's some pretty serious stuff going on with that. You had a question?
Oh, he asked my question.
Okay.
So, are you familiar with Rancher OS?
Yes.
Is it?
This
what are
would be a competitor, basically.
So, and what are the pros and cons?
Who makes Rancher OS? I don't even know.
Yeah, I don't know. Some guy.
So Rancher OS, yeah.
Rancher Labs.
Yeah, okay. So that's one reason, right? This comes out of the Fedora project. It's going to end up as an enterprise project from RHEL. So that's one thing that Atomic has going for it. Another thing I would say is that Rancher OS uses Docker as PID 1, so it doesn't have systemd. It doesn't have it fires up Docker and uses Docker to maintain itself and manage itself. And I would say it means it has yet to be demonstrated how good Docker is at doing that.
Yeah.
Any other questions?
Does your shirt say Unfakeable Linux?
Yes.
In reference to
Oracle's Unbreakable Linux. Yes.
I like it.
Yeah, there's a guy, Jan Wildeboer. He's one of our evangelists. He came up with that in a memo list is one of our internal places we yell at each other. And that came out of one of his, it ended up being a t-shirt.
Very nice.
On that same topic, we have a guy at work that he's a DBA, and he's an Oracle DBA, so he lives and breathes everything in Oracle. Now,
I'm sorry for him.
I know. Me too. Anyhow, so the problem is that we have a product that we ship out to our customers that's based on Red Hat Linux. We're signed in as a Red Hat distributor and whatnot. They're supposed to send me to get an RACE class, whatever, thing eventually, whatever. But anyhow, so but this DBA keeps on trying to push us to switch over to Oracle Linux because we could get it for half the price, and everything.
And a quarter of the support.
Yeah, as far as support, whatever. And so the only thing I could come up with as a legitimate business case to not do it is to say, okay, so Red Hat or Oracle is able to do this for half the price because they don't have to pay all the developers that Red Hat does. So what happens once Oracle runs Red Hat out of business? Are they going to raise their rates? And do we want to support that? So that's the only retort I could come up with. Is there anything else?
Oh, I have a lot, but I won't get into that here.
But I mean,
nor on
there's plenty
videotape.
of ethical reasons, but ethics and business have no
Sure.
no mixing, whatever.
We'll talk about it offline. Yeah.
All right. I mean, from the ethical standpoint, I got that covered.
Hey, any others?
I'm really interested in that too. I don't know.
Okay. All right. Well, I think we can call it a wrap then. Thank you.